For number 5, it's told that we need to assume that the following events are independent. If the events are independent, that means that the different events do not influence each other, and we can use the given formulas. So, if the probability that a high school senior eats breakfast is 0.8, and the probability that a high school senior will eat breakfast and get over 6 hours of sleep is 0.2, they ask us, what is the probability that a high school senior will get over 6 hours of sleep given that the person ate breakfast? So, this is going to use the formula that you get on the formula sheet. The probability of A given B equals the probability of A intersect B over the probability of B. Anytime we're in an A given B situation, and they tell me something given something, in order for me to plug things into my formula and make it pretty easy, I'm going to assign my A's and B's. So anything that happens after this line will be my given statement. A given B. So if I'm given that the person ate breakfast, I'll go ahead and say that B, that's my breakfast. And before that, a senior will get over 6 hours of sleep. So I'll say that's my A, because I'm A given B. So 6 hours sleep given that they eat breakfast. So A will be 6 hours of sleep. So then I can assign all of my probabilities. The probability that a high school senior eats breakfast, so the probability of breakfast is 0.8, and the probability that a high school senior will eat breakfast and get over 6 hours of sleep. So that and is the A intersect B, which will be 0.2. We can also know that it'll be the intersection because the probability will belong to the people who eat breakfast and the people who belong to the 6 hours of sleep. So if they belong to both of those categories, that'll be the intersection. Then we come down here and we are going to look for what we can plug in, what we know. We know the probability of B is 0.8, so I'm going to plug that in as my denominator. And then I also have the intersection of 0.2. And if I'm looking for the probability of A given B, I can say the probability of A given B equals 0.2 over 0.8. So all I did was assign my A's and B's, made sure that anything that was given was a B, and whatever we were looking for before that was an A. And then I just plugged in the probability of B using what I already found, plugged in my values, and I will get, this is going to be reduced down to 0.25.